Welcome to the Ralston College podcast. I'm Stephen Blackwood. By the age of 4, he was calculating the number of atoms in the sun. By the age of 23, he was considered the finest mathematician in England. Freeman Dyson was born on December 15, 1923. Educated as a boy at Winchester College, he came to the United States in 1947 and was appointed in 1952 by J. Robert Oppenheimer, a lifetime member of the Institute for Advanced Study in Princeton. There, and through various other collaborations, he worked alongside many of the greatest mathematicians and physicists of the 20th century: Albert Einstein, Niels Bohr, Wolfgang Pauli, Richard Feynman, Kurt Gödel, and John von Neumann, among others. He also had encounters with Ludwig Wittgenstein, T.S. Eliot, Stanley Kubrick, and many other intellectual and cultural lights of the century. But not only was Dyson a legendary scientist, he was also an amazing writer about science, exploring the great questions of the universe and of human experience, from quantum particles to the butterfly, from the origins of life to consciousness and the mind of God, quoting from Chaucer and Eliot, Shakespeare, Goethe, Dylan Thomas, Terence, and Tolstoy. But it was not the sheer power of his mind, or the lucidity of his written prose, as rare and as beautiful as both of those are, that principally drew me to Mr. Dyson, but his fearless independence of mind. Over the last 5 years of his life, I had the honor to correspond with him, to spend hours talking with him in his office, and to be his guest for lunches in the Institute for Advanced Study. We were thrilled when he gave to Ralston College the great honor of becoming a member of its Board of Visitors. His fierce intellectual independence, his willingness to go against the flow, his refusal to be cowed by consensus or pressure or authority, but only to follow the truth as best as he could know it, is the quality we most hope to cultivate in our students, in each other, and in our intellectual community at large, on this podcast and beyond. There were 2 things, above all, I wanted to know about Freeman Dyson. First, as an educator, I wanted to know, how did Freeman Dyson become Freeman Dyson, the courageous and independent thinker that he was? And second, as a philosopher, I wanted to know, what were the insights that his genius over nearly a century, with wide familiarity with science, history, literature, religion, and music, had yielded for him, peering into places that few can see, with eyes that few possess? Over the course of our conversations and correspondence, and of course by reading his books, I gained what for me are meaningful answers to both of these questions. I don't pretend that I came to exhaustive or comprehensive accounts of Dyson or of his intellectual life, many of the discoveries of which I don't even have the mathematical knowledge to understand, but rather that he gave me windows to see deep and wonderful things about himself and about the world. As to the first of these questions, his fearless independence, I came to see that this was really 2 distinct things. First, the ability to think independently, and second, the courage to follow his mind, to speak his mind, without fear. One could be independent-minded, but afraid to speak, or one could be willing to say anything, but lack intellectual independence. Dyson had both. When I asked him about this one day over lunch, he told me 2 stories. The first was about being at boarding school as a boy, at Winchester, a special place with very difficult entrance exams, and where rare gifts like his could flourish. Like most English boarding schools, Winchester has a chapel, and Dyson's first story that afternoon was about climbing over the roof of the Winchester Chapel at night. I think he said he was 12 at the time, and you can see what a wild feat that is if you find an image of the Winchester College Chapel, a 14th century Gothic building maybe 100 feet high. The exhilaration of that nighttime climb to the highest point of his world was still with him 8 decades later. Of course, climbing the chapel at any time, let alone at night, would have been forbidden, he said, But the schoolmasters at Winchester understood something very important, Dyson thought, about the kind of environment in which intellect and independence can thrive. That the rules were there not to stifle, but to help you soar. Climbing the chapel may be dangerous, but that doesn't mean there isn't anything to learn by climbing it. To realize what is in us, to become what we can become, requires that we take risks to encounter the unknown, to learn what we do not know. But the inverse is true too, that if we define our lives without risk, and especially if we define them as staying within the social or intellectual consensus of the moment, we will never learn what we do not know. And in some sense, insofar as fear of what others think defines us, we aren't thinking at all, but merely following. That formative latitude in Dyson's early education comes up in this interview when I ask him about a fact of his education that I had read about, but which in today's bureaucratized educational system would be considered impossible. Namely, that during his final year at Winchester, he had only 7 hours of class time per week. That latitude gave the students at Winchester the opportunity to pursue their interests with chapel-climbing ambition. Dyson and another of his classmates, who also had extraordinary mathematical talent, used the time to work through, on their own and in French, Camille Jordan's 3-volume textbook in 19th century mathematics, the Cours d'Analyse, a work that went far beyond what any of their teachers knew. The second story Dyson shared that afternoon took place after he left school and entered the war. He had worked in Bomber Command for the British Royal Air Force during the Second World War, and the policies and decisions of those in command, which in his view unnecessarily cost thousands of lives, had cured him forever of any unwitting respect for authority, any assumption that just because someone is in charge, they therefore know what they are doing, what is right, or what is best. Authority, for Freeman Dyson, or you could say power, had absolutely no inherent claim on truth. In today's interview, Dyson also mentions Eric James, one of his most beloved teachers at Winchester, who was a chemist, but from whom Dyson said he learned no chemistry, but rather to love poetry and literature. James, later knighted and made a life peer, became an important voice in education in England, arguing that teachers should be educated, not trained, and that inspiring the student was the foundation of teaching, a view that is about as far as you can get from the soulless technocracy of so much of what is called education, with its metrics and learning outcomes and credentials and mind-numbing uniformity in our world today. But I think Freeman Dyson knew what the antidote to all that was. He called himself an incurable Tolstoyan, in reference to Leo Tolstoy's experiment with a bottom-up approach to education, fostering individual freedom and creativity, opening one's eyes to wonder, by contrast with a Napoleonic top-down approach. And this leads to the second searching question that I, this time as a philosopher, had for Freeman Dyson, about what insight his genius had given him over nearly a century of learning and observation into not this or that phenomenon in isolation, but into the nature of reality itself. For when Dyson called himself an incurable Tolstoyan, I think he was not merely stating a preference for a certain vision of education, but telling us something about the very nature of things, of the universe, of the atom, and of ourselves. Freedom, for Freeman Dyson, is the nature of things. Many people today will assert that free will is an illusion, on the basis that the human being is controlled involuntarily by natural processes of which we are mostly unconscious. So the argument is that nature itself makes freedom impossible. But Dyson's account of the physical world at its most fundamental level, that of the subatomic particle, concludes the very opposite, that at that most elemental level, the universe is free. We cannot know in advance what an electron will do, because what it will do is, simply speaking, not predetermined, but free. This freedom, at even the atomic level, is no mere wishful thinking or speculative hypothesis for Dyson. As he says in our interview today, it's a fact. It's a fact with which our free will deniers and mechanistic modelers and top-down managers need to reckon. That freedom not only refutes a determinist standpoint, the idea that we are predetermined by forces beyond our control, that free will is an illusion, but refutes a reductivist materialist standpoint also, the notion that there is only matter and its motion, that immaterial or spiritual realities are illusory, because it shows that the view that there is only matter and its motion cannot even account for the motion of the matter at hand. It shows that we cannot describe the material world within the bounds of matter itself. The concepts, language, and reason that are necessary to describe matter are not themselves material, but rather intelligible realities. But Dyson takes the argument much further. For him, matter itself is not simply material. As he writes, quote, "Matter is an imprecise and old-fashioned concept. When we examine matter in the finest detail in the experiments of particle physics, we see it behaving as an active agent rather than as an inert substance. Between matter as we observe it in the laboratory and mind as we observe it in our own consciousness, there seems to be only a difference in degree, but not in kind." End quote. Mind and will are already inherent in every electron. The freedom of our thinking is thus not only not an illusion, it is the very nature of reality as self-developing all the way down. Particle physics, for Dyson, therefore reveals at the minutest level something fundamental about the nature of life and nature, about the nature of ourselves, that life is free. It is not coerced or predetermined, but unfolds according to inner principles that are not materially reducible. That inherent freedom is not an empty or an abstract one, however, as though anything can become anything else, but rather an actualization of an inner natural potential. That potential can only be realized in a context, in and against which it is brought out and actualized. In fact, it's precisely because things are not predetermined that the context in which something can be realized matters so much. And that brings us back to the image of Freeman Dyson as a boy, on the roof, at night, of Winchester College Chapel. The school at which that was possible understood something fundamental about how human potential is realized. It isn't inevitable or foreordained. It can only come out, only unfold, if it has, like a seed that needs nutrients, water, and sun, the context in which it can be actualized. For human beings, that requires a context in which our nature as thinking beings can be cultivated. So we become capable of self-development, of freely determining ourselves in relation to the truth our minds enable us to see. Freedom of thought is not, therefore, simply a technique for discovering new knowledge. It is the very substance of what human nature is. The inverse is true too. The suppression of freedom of thought is the suffocation of human nature itself. Intellectual independence is thus an antidote to nihilism, to what's the point defeatism and deterministic surrender, and to coercion of any and all kinds, because it affirms the inherent freedom and thus the purpose of life itself. Every particular life, every person, every choice, everything. And so Freeman Dyson's radical intellectual independence was not merely a manifestation of the self-developing character of the universe, shown in the evolved diversity of species and the movements of subatomic particles, but the realization of a free human nature. That insight holds the key, I think, to the regeneration of our cultural, intellectual, and institutional life, namely, the cultivation of forms of life and culture that foster that very freedom. For that to take place, we'll need many more independent minds, intellectual heretics, as Dyson himself put it. We need more heretics, he said, young ones especially, and for that, we'll need nothing less than a revolution in education, because you don't get Freeman Dysons from an educational system designed to produce conformity with the status quo. And for that, we'll need new schools and colleges, and perhaps things yet to be invented that cultivate chapel-climbing adventurers and intellectual heretics, places that understand that the universe is truly infinite in all directions, as Dyson himself put it, and above all, that the human being is made for that infinity. The only way to become ourselves is to have the courage freely to know and love our own irreducible, infinite particularity, in which the unbounded prodigality of mind and life is revealed and made real in us. You are the universe's unfolding. I am very grateful to have known Freeman Dyson and to have had the chance to interview him just a few months before he died, on February 28th of this year. May he rest in peace, and may he inspire many more incurable Tolstoyans. I'm Stephen Blackwood. Thanks for listening. Well, thank you so very much for making some time to chat with me, Mr. Dyson. Is Mr. Dyson a good way to address you, by the way?
Yes, I think so.
Okay.
I mean, I'm one thing I'm not is a doctor.
Well, that's actually a rather interesting place to begin our conversation, because many things I'm very excited to ask you about today, but one of them certainly is educational institutions and your own experience of both educational and research institutions. And I know you've written at one point about the problems with the PhD system.
Yes.
Would you say a word about that, maybe? Just that seems a natural segue after you're talking about the fact that you, Freeman Dyson, have accomplished all that you have accomplished in the intellectual world without having the letters PhD ever attached to your name.
Right. And I think the PhD system is doing a lot of harm. It was designed for German academics in the 19th century, and for them it was certainly well designed. If you're going to be a professor, the PhD system is quite appropriate. Unfortunately, it's come to be a kind of union card everybody has to have who does any kind of teaching job. It's a great waste of time, it's inappropriate, and it causes a lot of harm, especially to women, but just by taking up the most productive period of their lives and stopping them from conveniently raising families, and which is necessarily a great burden on women. So I've seen a lot of harm being done. I've had sort of 3 disasters in my own career in which I invited people to come to the Institute for Advanced Study, and they suffered mental breakdowns. One of them was a suicide. 2 of them ended up in mental institutions. So I feel responsibility. These are vulnerable years, and I think things have improved since everybody now has a smartphone, so they can talk to their mothers when they feel like it, and they don't have to be so isolated as they used to be.
Yes. Mr. Dyson and I are just speaking here about let's call them the perversities of the PhD system. And you've made a very interesting point, I think, about the way in which it particularly is disadvantageous to women. I suppose it gets at really a fundamental question, too, which is that the intellectual life in its true form is not subject to externalities. And so whether you have a PhD or not has no bearing on whether you know about physics or English literature or Russian grammar or anything of that sort. Whether you have a PhD has no bearing on whether you know what you're talking about. It really is a very problematic thing to have at the heart of particularly the highest levels of research in the university, to impose that externality, which is unrelated to the question of whether someone knows what they're talking about.
I wouldn't quite go that far. I mean, I would say for the people who have a dedication to an academic life, it does make a difference. It's often very helpful. It's simply applied inappropriately to 10 times more people than it's suited for.
Yes, yes.
For the 1/10 for which it's suited, it's fine. And so I wouldn't say it should be abolished, just that it's inappropriately applied to far too many people.
Yes. On that topic, though, do you think it should theoretically be possible to have a career at the university without having a PhD?
Yes.
Yes.
Of course, that was so in England when I grew up. That's how I escaped from the trap.
Yes. Well, one of the teachers of many of my great teachers never had a PhD, and he was always spoken about in hushed tones because he was such a great intellectual figure he was.
Who was that?
His name was James Dowell, and he was a philosopher, Canadian philosopher who spent, I think, his whole life in the 20th century, but was the teacher of many of my great teachers and had a truly great philosophical and linguistic, indeed, mind. And so I would certainly agree with you that there can be meaningful forms of certification, such and such as pass this exam or that exam. But as soon as the university or educational institutions become ossified with respect to certification in that rigid sense, it seems to me they may be closing themselves off to many great talents who either do not need to jump through those hoops, so to speak, or who have already arrived at a high level of mastery of a certain field without having to go through those.
Yes, and but I would say what is so wrong about the PhD is just that it takes far too long. Now, there are some people who get through in a couple of years. That's fine. It hasn't done them any harm. But when it takes 6 or 7 years, as it frequently does, then it really is doing harm.
Well, that's a good moment to shift into maybe a bit of conversation about educational institutions and your own experience of them. I have always loved the stories of your early education at Winchester. I think I have a quotation here from one of your accounts of this when you say that you arrived at Winchester and met some kindred spirits, one in particular who had as great a love for mathematics as you had. And you say that independently, the two of you, I think, worked through, is it Jordan's 3-volume Cours d'Analyse?
Yes.
Is it a 19th century French? It was a textbook at the École Polytechnique in Paris.
Yes.
And that you worked through it entirely on your own. And you say the teachers at Winchester wisely left us alone to educate ourselves. They gave us wide freedom and were confident that we would use it responsibly. In our last year at Winchester, we spent only 7 hours a week in class.
Right.
I think to anyone of my generation or younger, it's an astonishing thought that someone could be in school in formal instruction so few hours, whereas today many children are very highly scheduled from dawn until dusk.
They all are, yes. No, I'm appalled at the way my grandchildren live. I mean, they're always being driven around from one obligation to another, and when they're not in school, they're doing intensive sports or intensive music or intensive something or other. They have hardly any time to get bored.
Do you think boredom is important?
Yes.
And why is that?
Well, that's the most creative time when you develop your own thoughts, when there's no input.
When you were You are, of course, renowned for having a certain independence, a great independence of mind. How did that come about? How was that fostered in you, or was it simply innate, or were there experiences that cultivated and developed that?
Well, I think both. I had the great luck to be growing up as a teenager during World War II, when the whole system was screwed up. And so we had, at Winchester, we had a great shortage of paper because at that time, England was importing necessities of life, but there wasn't room in the ships to import paper.
Is that right?
So that without paper, you couldn't have examinations. There wasn't such a thing as an oral exam. And so examinations stopped. And that was a great piece of luck.
Really? That there were no examinations?
Right. Well, that's a little bit of an exaggeration, but at least, they were greatly reduced anyway. And there was a lack of teachers, of course.
So were those formative years for you at Winchester in which your learning was, I take it, largely self-directed?
Yes, it's not true entirely. There were some excellent teachers, but they had time also to give us individual attention. So my favorite teacher was Eric James, who afterwards became Lord James and ended his life in the House of Lords. And he was a young chemistry teacher and loved to talk about poetry and other things besides chemistry. So I got to know him as a friend, and so he was actually contributing a lot to my education, but not by sitting in class.
Yes, I think that's something of the paradox that, of course, it would be completely wrong to say we don't need educational institutions. They're absolutely of fundamental importance. Human beings don't come to their full actuality just by being left alone. On the other hand, the highest development of the human being seems to require a significant degree of freedom.
Yes, I have a young friend who comes to see me here from time to time. His name is Umar. He's an Indian who, I don't know where he lives exactly, but anyway, so he's now about 15 years old, and he's immensely well educated, totally online. He goes online to it's called Stanford Online High School, and which means he communicates online with teachers and with other kids who are enrolled. But he says he actually has a lot of personal contacts. That it does not mean that he's just getting stuff online and sending it back. He's also talking a lot with his teachers and getting personal attention. But he's got complete freedom to spend time with the teachers or not. He's never sitting in class. And I think he's one of the best educated kids I come across.
You've written using a beautiful metaphor, a very powerful metaphor, I think, about the contrast between Napoleonic and Tolstoyan visions of education, and indeed visions of reality more broadly construed, perhaps as well, science included. And just for our listeners, I'll give that a quick gloss as, and would you agree, Mr. Dyson, that the Napoleonic in your account is a kind of top-down vision, whilst the Tolstoyan is a kind of bottom-up vision? If in Napoleonic it's a big system in which the individual is, as it were, forced to play a particular part, in the Tolstoyan vision, the individual's place comes out somewhat more spontaneously or out of the life of the particular individual, him or herself.
Yes, the fact is, of course, that Napoleon created the modern European education system. It was an amazing achievement. He actually sort of educated all the children of Europe while he was alive, and his system has endured. You find all over the continent of Europe, the Napoleonic organization of schools, exams, and especially the sort of elite-driven education. It's designed for the elite who will actually be organizing the whole society. So it puts a scholarship within reach of kids of all kinds, rich and poor. So it did an enormous amount of good to a large fraction of these populations. But, of course, it has the downside, which is the kids who are turned off. And I've seen a lot of those still. In the United States, of course, it's not Napoleonic. We still have local control of schools. But still, the system is still fairly, it's organized on Napoleonic lines with
Yes.
fixed standards and standards imposed by states. And those very often are inappropriate. And so there are a large fraction of kids who are turned off history or mathematics or science, but by having to listen to boring lectures.
Yes, there's a remarkable degree of homogeneity and you might say regime-like standards and demands throughout the entire, so to speak, system.
So it certainly helps one group of kids who need to be spoon-fed, and it's very bad for the minority who react against it. And
I think in one of your writings you've called yourself an incurable Tolstoyan.
Yes. So Tolstoy, of course, took the opposite view. He established a little local school on his own estate for the peasants, the kids of the peasants, the serfs who lived on his estate, and he actually taught them himself, and using the opposite philosophy that he was concerned with the kids as individuals. He wasn't trying to teach them a curriculum. He was just trying to teach them to think, and it worked very well, but it only lasted for 2 or 3 years. Unfortunately, he got bored himself, and so he didn't follow his own principles, and so the kids were left, after 2 or 3 years, left to their own devices.
So when you call yourself an incurable Tolstoyan, what do you mean?
I mean, I agree with what he said, not with what he did.
Yes, of course. But how would you characterize the Tolstoyan nature of your own, say, spirit?
Well, it's simply that I like to find things out for myself as much as possible, and I get along well with teachers on an individual basis, but I go to sleep if I'm listening to a lecture. That's still true.
One thing that you write that pertains to this, Mr. Dyson, that I found extremely interesting is that you associate something of that Tolstoyan freedom with the cultivation of scientific curiosity and also of artistic expression. But one way of asking this question is where do great scientific discoveries come from? There's a certain, let's say, popular idea that scientific discovery might be simply a matter of plodding along in the lab or so to speak, and I know there's a great deal of plodding along in any serious discipline. But the great discoveries, you seem to, if I'm not mistaken, seem to associate them with imagination and with a certain curiosity. Why is that so?
Well, there are many different kinds of people and many different kinds of science, and so nothing you say applies to all of them. So, I mean, there's a lot of science which is necessarily a big group effort and what they call big science, which is real and it is important. And it gets, of course, most of the public attention. So big projects are very often fruitful. But then there are a very much larger number of discoveries are actually made by small groups, usually a few people with students doing most of the work and a mentor who is giving them problems to work on. And my mentor, Charlie Kittel, just died yesterday.
Oh, I'm very sorry to hear that.
At the age of 102.
Really?
So he had a very good life, and he had a wonderful gift of providing he had a lot of students. He was a condensed matter physicist, and he had this gift of being able to provide a problem for each student which was exactly hard enough and not too hard, so it was appropriate to the student. So that's what he did for me. He gave me 3 problems, each of which I solved with a great deal of effort and learned a tremendous lot.
When you think about your most creative or the most powerful work or the most powerful thinking you've done, I suppose the question I would like to ask you is, how does one cultivate in the young, insofar as their abilities allow them, of course, a spirit that allows them to think imaginatively or creatively?
Yes, I would say it's done mostly just by setting a good example. I mean, I got to know Richard Feynman when I came to America. It was immense luck. I never heard the name of Feynman before I came, and there he was at Cornell University. After 1 week, I recognized him as a genius, and so sat down to learn as much as I could. This amazing fellow who sort of rebuilt physics from the bottom up himself and had all kinds of original ideas. So he was my role model, which was certainly very important, and so I learned more from him than anybody else. So that's only one way. I mean, then the other way is by reading books. That's also very helpful. And I mean, one of the favorite books which I treasure is this one, which I've been reading so much, so long, so the back is fallen off.
Oh my goodness, I see this is... What is that?
And that is a school prize from my high school. So it was...
See the inscription in Latin here? Men of Mathematics by E.T. Bell.
That was an amazing piece of luck. It was published just before I was a teenager. I forget what it says about the...
I think I saw the date of 1937.
Yes, anyway, that was the time. That was when I was 15, so it came into my life. So that it's biographies of mathematicians, and it's written in a very lively and personal style. And what was... I mean, Bell was not a reliable historian. And the experts, of course, complain he made up a lot of stories himself.
Yes.
But they're good stories, and he gives you a real picture of these mathematicians as people with faults, people with all kinds of problems, and very often unpleasant people, but still somehow driven by this love of mathematics. And so if you're a teenager reads that book, the effect is very strong. You feel if these people could do wonderful mathematics, then maybe I could too. And they're not just geniuses, they are very human. And so I think he did a lot of good. My generation was raised on that book, and so it actually turned a lot of us into mathematicians.
It seems to be so very important that there be stories and examples that can inspire the imagination of young people.
Yes, and that's precisely what he was doing. And of course, Bell himself, he was a professor at Caltech, and he actually was not a great mathematician, but he understood great mathematics.
It seems to me that a discovery of any kind is based on being able to imagine something that is not the way things already seem. Within the realm or the bounds of how we understand things now, the new is not possible. The discovery of something new means being open to the revelation that things are not as we have hitherto understood them.
Yes, of course. I mean, the fact is there are so many different kinds of science that the very great scientists are the ones who are sort of driven by a long, sustained study of particularly important problems. And I mean, I think of Ed Witten in the room next door, and he's, of course, spent his whole life studying important problems which are deep and continued for 40 years with a sustained, intense, hard work on what are really the big secrets of nature. And I don't do that. I mean, I'm much more like a musician playing the violin. For me, mathematics is just an instrument that I enjoy playing, and I don't care whether the problem's important or not. If it's an interesting puzzle, I enjoy playing it, and so that's what I do. And so some of the best things I've done have been completely unimportant. And so from a point of view of the big problems, I'm wasting my time. But I don't care. I mean, for me, science is just something I enjoy, just the way my father enjoyed conducting a choir, and he was a musician who...
Oh, yes, I know some of his music.
Yeah, anyhow, so, I mean, my gift is similar to his, and he always said he liked to write music for a particular group of people to play or to sing. And I remember once I asked him, because we had always musicians in the house, and all his friends tended to be musicians. And once I asked him, how does it happen that among all these musicians, you're the only one who is not crazy? And he said, thank goodness I'm not Beethoven.
Yes.
And so I have the same feeling. I mean, thank goodness I'm not Ed Witten. I mean, for me that would be a great burden. I have a short attention span. I like to work on a problem for a few weeks, and then either finish or stop it and turn to something else.
Well, returning to the question of the independence of the mind, I think it's safe to say that we're living in a time, particularly in our, let's say, public discourse, in which there's a great deal of opprobrium cast on people who hold this view or that view. We don't need to get into particulars, but there can be quite a bit of bullying, trying to bully people into having one position or another, or making it difficult for someone to hold a view because it's not socially acceptable to hold it. I'd like to ask you a little bit about this, because you've had demonstrated a great deal of courage throughout your life to hold views independent of what others might think. And so a couple of questions about this. The first is, would you agree that the very idea that one can be bullied to hold a view has at its heart a disbelief in truth itself? Because
no, that's not true. I wouldn't agree with that at all, because I've seen a lot of very sincere bullies, and that's, I mean, I think of Richard Dawkins in particular, who's a sort of policeman for the orthodox views in biology, and he bullies people quite mercilessly. And he really believes what he's saying, and he's very, very sincere, and he's actually an excellent biologist himself. He's contributed a lot to understanding evolution, and it's just his nature that he likes everybody else to think the same way he does, and that's the reason bullies are so effective is because they are sincere, and the people who disagree with me about climate science are very sincere people. I mean, it's amazing to what extent they are driven by a feeling that they really are in possession of the truth.
Yes. I should restate that because I can entirely accept your correction of what I've said. It's not based in a view that truth does not exist. What I'm trying to get at is rather that the status of something as true is independent of coercion. So that is to say, my bullying someone to believe something has no purchase on whether that view that I am advocating is true or not.
Yes, I mean, of course, the whole history of science is full of firmly held beliefs that turned out to be wrong, and
yes,
that's the way science works, and it gives you a picture of the universe which is not as anything like as rich as nature itself, and but you tend to believe the picture rather than looking at nature.
Of course, we all, in a way, want to be right. But one of the stories that you tell that I found most moving was of your early days at Cornell when you were working on having what seemed like great progress, working on a problem which you then took to, is it Enrico Fermi?
Yes.
In Chicago?
Right.
Would you recount a little bit of that story to us?
Yes. Well, Fermi was a great physicist who was, I think, one of the very few who was first class both in theory and in experiment. So he was one of the creators of quantum electrodynamics as a theorist, and he was also worked out the theory of weak interactions, which was mostly Fermi's creation. But in addition to that, he ran a big experimental lab in Chicago and also earlier in Rome, where he did wonderful experiments, and so he did both. Anyhow, so he was measuring the interaction of high-energy particles with strong interactions, that's mesons and protons. So he had this big machine in Chicago. This was after World War II, and it was around 1952, 1953, but his machine was actually ahead of anybody else. He had more or less designed it himself. So he was doing these beautiful experiments on meson scattering by protons, which is a way of measuring directly the strong interactions. Well, I was trying to work out the theory of strong interactions with a group of graduate students in Cornell, and we did a big calculation of the meson-proton scattering using our version of the theory. And our theory was the best we could do. It was a sort of a copy of the electrodynamics, the theory of electricity and magnetism, translated into strong interactions, and with a lot of fudge factors to agree with the observations. But that was the only theory we had. Anyway, so we did these calculations, and the students were very happy. They were working hard, and all of them working for PhDs. And so we had lots and lots of curves. And Fermi had also curves. So we were supposed to fit his experiments with our theory. And we thought we'd succeeded, and the curves looked very much the same. So I was very excited about this, and I was going to let Fermi actually see our curves before we went public. And so I took the Greyhound bus to Chicago and made an appointment to talk with Fermi. And I arrived at Fermi's office, and with great pleasure I gave him these papers with our curves written on them and his points, showing how well they agreed. And the response of Fermi was a shock. He didn't even look at my curves.
Really?
He knew what was on them anyway. He'd heard about this from his friends. And so he looked at me very seriously, and he said, yes, you know, there are two ways of doing theoretical physics. There's one way which I prefer, which is to have a clearly defined physical model. The second way, which I also use sometimes, is to have a well-defined mathematical formalism. You have neither. That was sort of the end of the conversation. He just saw intuitively that our theory was a hodgepodge. It had no really clear physical picture and also no consistent mathematics. It was essentially sort of an attempt to find a recipe for cooking a soup without knowing what you were putting in. And
Yes.
so anyway, he said, that's not the way. It is, he said, how many parameters did you fit? How many parameters that means numbers that you, fudge factors that you put into your theory to make it fit my experiment? And I said 4. There were, in our model, there was actually 4 parameters: the strength, the mass of the meson, the strength of the interaction, and a couple of other things. And so you had 4 numbers to fit these rather simple curves. So Fermi said, yes, my friend Johnny von Neumann, he used to say, with 4 parameters I can fit an elephant, which of course is true. And so if you have that many parameters, fitting the experiments is much too easy. It doesn't mean the model has any meaning. It's just a numerical accident. So anyway, I came back to Cornell and told the students, unfortunately, the theory is no good. You better find another line of work. And
what's always struck me about this story, Mr. Dyson, is the gratitude you expressed towards Fermi for
Yes.
having freed you of what you might say were illusions or at least mistaken ideas.
Right. We would have gone on for years doing these calculations if he hadn't been so firm. And
I suppose that's what I would like to ask you about, is about the role of intellectual humility. I mean, all of us want to be right, but if we wish to be as close to what is true as possible, we have to always be open to admitting
Yes.
that we were wrong. And that goes back to the question of coercion, that the nature of truth is not coercive. And so that is to say that, at a certain point, people thought the world was flat, but no matter how invested they were, no matter how passionately they defended that view, no matter how coercively they tried to make others believe that, none of that had any influence whatsoever on whether the world was flat or not. Whatever is true is independent of what we might want to be true.
well, of course, it depends what you mean by being true. There's so much ambiguity in language, which, of course, that's what philosophers do, and it's
Yes, of course.
but it's the beauty of language that it allows this kind of vagueness, which is actually the way we live. I mean, the language is a way we organize things we don't understand, but it's absolutely a wonderful device. And it is, language is sort of the greatest of the arts in a way, and
Yes.
it's the lack of precision is absolutely essential. And when you try to make language precise, you get something like the Whitehead and Russell Principia Mathematica. I don't know whether you've ever studied that.
I have not studied it.
Oh, well, anyway, these were 2 philosophers who tried to be mathematicians, and it was a monumental failure, but it led to huge discovery of Gödel. I mean, it was the title of Gödel's paper actually cites Whitehead and Russell. He actually uses Whitehead and Russell as his model of how mathematics doesn't work, and it's so in a way their mistakes led him to the truth. And
yes, I wanted to bring up Gödel actually, because when I say that truth is not subject to coercion, I'm only making a very basic point that whether someone wants something to be true or not is unrelated to whether it is true. But there's a related point that I think is one of the highest importance, and that has to do with the non-reductive quality of reality in its richness. In one of your books, you mentioned that the mathematician David Hilbert spent the later part of his life aiming to find a kind of to develop a kind of reductive system that you could plug anything into it and it would tell you whether or not it was true. Have I got this right?
Well, it was only a small part of his thinking, but it was certainly there. And he talked about the Entscheidungsproblem, and the Entscheidungsproblem is the decision problem. And he was searching for a sort of infallible way of telling whether a mathematical statement was true or not. And of course, he never found it, and Gödel proved that you couldn't find it. And
you have a description of Gödel's theorem, which I'll read here, because I think this gets at a very fundamental question about the nature of reality itself. By contrast to Hilbert's effort to reduce everything, you say, Gödel's theorem shows conclusively that in pure mathematics, reductionism does not work. To decide whether a mathematical statement is true, it is not sufficient to reduce the statement to marks on paper and to study the behavior of the marks. Except in trivial cases, you cannot decide the truth of the statement. It comes out only by studying its meaning and its context in the larger world of mathematical ideas.
Yes. In fact, that we have the mathematics is an art as well as being a science. And we are free to create mathematics by setting the rules ourselves and seeing how they work out.
I know you always are very careful to say that you're not a philosopher or a theologian, but have you given any thought to what the principles of reality must be such that our thinking is possible, but that reality itself is non-reductive? What I'm trying to get at here is, philosophers speak about a dialectical thinking in which two things which are opposed can both be true, but in the opposition of those two, one is able to move to a deeper or more comprehensive account of things. And so it's not a fixed, let's call it mechanistic standpoint, but one that affirms the actual diversity of reality itself.
Yes. Well, of course, Niels Bohr was the strongest advocate of that point of view. He called it complementarity. And I think that was, Bohr, to me, it was the one who really got it right. And I think, complementarity is built into the universe in a very general way. And of course, the example that Bohr was concerned with the quantum mechanics, and you cannot understand quantum mechanics just by looking at nature in one way. You have to look at it in two ways, which are both true but cannot be seen at the same time. And
yes, you have a beautiful line in, I think it's in your account of, I believe it's the lectures you gave at Aberdeen, the Gifford Lectures, which I think were initially called In Praise of Diversity.
That's right.
And then, which is itself a lovely title, and then beautifully retitled Infinite in All Directions, which is a wonderful phrase, Mr. Dyson. And you say, quote, Diversity is for me the chief source of beauty and value in the natural universe around us, in the governance of human societies, and in the depths of our individual souls. The profusion of stars and galaxies in our skies, the profusion of bugs and beetles in our gardens, and the profusion of human genius in our arts and sciences all proclaim that God loves diversity.
Good. As I had forgotten that, but it's a good sentence. Yes.
I suppose what I want to get at here is the question of the non-reducible character of reality and the relation that has to the bottom-up thinking that we earlier described as a Tolstoyan approach. The infinite diversity of the natural world is analogous to the freedom of the mind itself, because thinking is itself an infinitely self-developing, bottom-up activity. Does that make any sense?
Yes. Yes, it certainly does. But there is, I would go much further now. I mean, the last thing I've been doing, insofar as I do any serious thinking, it's about evolution. And did you read the piece I just published about evolution?
I don't think I've seen that yet.
No, anyway, it's on the Edge website, which is, it's John Brockman's website, which he asked me to write something, and so I wrote this piece for him. And
tell us about it.
I can give you a copy. I think I have a few spare copies. Anyway, I mean, it's called 6 Characters in Search of an Author, and which is a play of Pirandello, and so I got my 6 characters lined up, and I think it's a very fresh view of evolution. And so one of the 6 characters is Moto Kimura. I don't know if you know his name.
I don't.
No. Anyway, Moto Kimura was a Japanese evolutionist who studied evolution, and he wrote a book called The Neutral Theory of Molecular Evolution. And he was still alive when I was working on this. Actually, I corresponded with him. So he was quite recent. It was about 100 years after Darwin. And anyway, of course, he didn't say that Darwin was wrong, but he said Darwin's very seriously incomplete. And anyway, so he incurred the wrath of Richard Dawkins and was sort of declared to be a irredeemable heretic and expunged from the biological dogma, and because he was supposed to be against Darwin. He really wasn't against Darwin, but he added a tremendous lot to Darwin. And anyway, he lived in rather considerable obscurity. He was shouted down by the biologists. But I think his vision is right. And what he's saying is that evolution is a high-risk strategy. You don't take big risks, you don't evolve. And nature knows that. So nature is playing the odds. Then the next person on my list of 6 is, I'm forgetting names, that's my old age. But
not to worry, we can always find it later.
Yes. Anyway,
it's in the paper.
Yes, anyway, I'll find it. Anyway, Ursula is another biologist who is still alive, and she made what I think is a crucial discovery, which she was not able to publish because it goes against the dogma. And
she made a discovery she was not able to publish because it goes against the dogma. That's an astonishing statement.
Well, it's true, and she doesn't want it to be talked about. I sent this paper I wrote. I sent it to her and asked for her approval, and she said no. And She wants to be remembered as a successful experimenter, not as a victim of prejudice. And I think she's right. I mean, for her personally, to be a victim is not a good thing. And
of course.
it's much better to be celebrated for the experiments, which nobody can deny. And so she does publish her experiments. And anyway, so what she discovered is if you look through the animals and plants that have sex, it goes back about 1 billion years. And sex was invented by algae, seaweeds, and the algae, I mean, they still have sex, but there's very little difference between male and female. It's just they invented the system. And then the plants and animals developed this much further, of course, with these elaborate mating systems. Anyway, so Ursula's discovery is, if you look at all these sexually reproducing species, that you find that all the genes that are actually regulating the mating preferences mutate about 10 times as fast as other genes. So it's a big, very powerful difference. So the mating systems are designed to change rapidly. And why should that be so? Of course, the fact is, you can't deny the fact that she observed experimentally, but her interpretation is what is at stake. And so her interpretation, which I think obviously is right, is that this is nature's high-risk strategy, that nature actually makes it very hard for us to have offspring. So most of the possible mates have different mating preferences that are changing rapidly, so the chance of finding a compatible mate is reduced. So everybody has a reduced Darwinian fitness by design. And so it is, in a way, anti-Darwin.
Is that what makes it unpublishable, unacceptable? Yes,
precisely. And so the question is, how could nature possibly do that? And so Ursula says it is simply the way nature makes new species, that when you have a population with mating preferences that are changing rapidly, there will be an increased chance, by a big factor again, that you have two happy individuals whose names happen to be Adam and Eve, who have both the same matching shift in the mating system. So they can mate, but nobody else can mate with them. And that means a new species. And so it's nature's designed to make new species occur much more rapidly at the cost of the individual. And I think this is absolutely right. It is, because that is sort of, it's the mother of diversity, that you have this profound tendency to make new species, even when they're not fit in the Darwinian sense. And most of the new species, in fact, are total failures. Most of them never get beyond a few generations. The few that get past the barrier and get so the small population barrier where inheritance is random, and you finally get to the big population where you're secure, and those are just a very small fraction of the new species, but still give us these millions and millions of different species which make nature beautiful. And Anyway, so that's the pitch. So that the diversity is not just consequence of random chance, which is what Kimura was saying, but it's actually by design. And
diversity by design, evolutionarily.
yes, evolution is in fact a device for forming new species, which is what Darwin actually said. I mean, he called his book The Origin of Species, which is precisely right. And
yes,
but he didn't understand the mechanism.
You have a lovely quote from a quotation by H.G. Wells, also in your Infinite in All Directions, in which he speaks of the coherency and purpose in the world.
Yes.
Could you say a word or two about coherency and purpose with regard to what you've just been saying about diversity?
Yes, well, of course, I mean, evolution is, to me, the driving force of the universe at all levels, all the way from the galaxies down to the genes, and it's a process that's taking this very boring dilute gas, which started with the universe, nothing but hot hydrogen and helium, and it evolves by this process of segregation of hot from cold and solid from liquid, and all these phase transitions which create diversity and give it a purpose. The purpose is emerging from this process of evolution, and I'm not saying it knew ahead of time what it was going to do. Purpose emerges gradually, but in the end, that's the driving force. And
what might we call that? A kind of emerging coherence to diversity, as opposed to sheer randomness.
Yes, well, it is random. It's using randomness as a creative force.
Yes, but things don't simply go into infinitely incomprehensible forms, but there seems to emerge a kind of coherence in and through the infinite diversity.
Yes, and of course then humans, of course, are something special. That it really was a big jump from the apes to the humans, and I think it has a lot to do with the environmental disasters. That far worse climate changes that have happened are the ice ages. They're much worse than any kind of global warming that people are so scared of today. And the ice age really does wipe you out. And
yes,
and that, I think, has a lot to do with the emergence of humans, that we had to be a lot smarter to survive those. And it probably was the driving force. We had this succession of ice ages for the last 2 million years or so, and a large variety of species which are now extinct. And then the last part of the story, of course, is Svante Pääbo. He's the sixth of my 6 characters. This Svante Pääbo, who discovered that we are really Neanderthals. And have you read his book?
I have not read it.
No, it's called. The title is something about the evolution of Neanderthals or something. Anyway, yes. He sequenced the old Neanderthal genomes, the 50,000 years old, and it was an amazing. It was a triumph of big science. I mean, you had to sequence those genomes just out of tiny fragments of bones, and it was a huge undertaking, and he managed to do it. And then what he found, to everybody's amazement, was Neanderthals are not extinct, that actually they merged with humans, and we simply sat around the cave fire telling stories and having babies. And So we ended up 5% Neanderthal or whatever it is.
And why do you consider that to be an important discovery?
Well, because it shows that our evolution is now cultural, not biological. That so culture is now driving evolution much faster than biology, and that's how we got through the ice ages.
This is an absolutely fascinating point, and it may be a good time to speak about consciousness. You have a wonderful phrase here, which I'll read here for our listeners. You say, and I quote, "I think our consciousness is not just a passive epiphenomenon carried along by the chemical events in our brains, but is an active agent, forcing the molecular complexes to make choices between one quantum state and another. In other words, mind is already inherent in every electron, and the processes of human consciousness differ only in degree, but not in kind, from the processes of choice between quantum states, which we call chance, when they're made by electrons." Now that's a difficult sentence, I know, and for our listeners, just stick with us for a few minutes while we take it apart, little by little. First of all, Mr. Dysett, what do you mean when you say that our consciousness is not just a passive epiphenomenon carried along by the chemical events in our brains?
Well, I mean, the fact is that quantum mechanics says very clearly electrons make choices. And with quantum mechanics, the electron is a wave. The wave consists of probability that something will happen, but you cannot tell in advance what will happen. So the electron is making a choice, and that's a fact. And you can interpret it, of course, say, well, this is random chance. You just use the laws of probability. That's the best you can do. And I'm saying it's not quite so simple, that, in fact, the classical world is also real. Before the event, you have probabilities. After the event, you have facts. And so after the event has happened, you know what the electron actually did. And so the electron did, in fact, do something active, which is not too different from the way we are actually functioning with what we call consciousness. And
there's a very prevalent view that, well, let's just say that determinism is a very prevalent view, a kind of reductivist materialism. There is nothing outside of matter and its motion. What seems to be going on in your account of this is something more than that.
yes,
That is to say that mind, when you say that mind is inherent in every electron, please correct me if I'm wrong here, you seem to be saying that there is an inherent non-deterministic freedom, even at the atomic level.
yes. So I would say, I mean, my view is, which is purely hypothetical, and there's no evidence at all, but my view is the brain is essentially an amplification device, that it takes molecules inside the brain which carry information and amplifies their effects so that they become large scale. So it just takes individual molecules which have this quantum freedom, which is the electrons which are moving around, and the brain somehow organizes that to produce larger effects. So it is basically an amplifier.
One way of getting at this question is what I take to be a kind of, let's say, aggressive reductivist materialism. One sees this popularly in the idea that only the findings of empirical science are really real. That's a widely held view, I would say, which would then discount non-material realities as having any reality at all. So, for example, tell me if you think this makes sense. In its bare form, the mathematical equation, 2 plus 2 equals 4, is a non-material truth.
Yes.
It shows up, of course, in all kinds of material ways, but its standing as truth, or the truth of that equation, is non-material, that is to say, intelligible.
Yes.
And that seems to, of itself, indicate that the idea that only material things are real is false.
Yeah, well, the word real is used in so many different ways. And so I don't regard that as false. It's just it's a statement that you can agree with or disagree with according to what you believe the word real actually means. And
yes, of course. What I'm trying to get at, I suppose, is that if one has a reductivist, materialist standpoint, one is unable to account for what's going on in, say, consciousness or beauty or love, or I suppose even in pure mathematics.
That's right, yes.
So is it safe to say that in your understanding that the nature of things, or we could say the nature of reality, the nature of things is both non-reductive and inherently free?
Yes. But I like to look at it from a point of view of physics, which is where I'm at home. And so the universe has this two-level structure, and they are both true. The word true, of course, also is very ambiguous, but both the two layers are true, or both real, whatever you like to call it. But you can't see them at the same time. And roughly speaking, the quote which I like to, I don't know whether it's in that book, but anyway, the quote from Bragg, or that's Lawrence Bragg, the crystallographer. And when quantum mechanics was discovered right away at the beginning, it was in 1926, when just after Schrödinger wrote down the Schrödinger equation, Bragg made this, which I think is a wonderful description of the universe. You look in the future, you see waves. You look in the past, you see particles. And I think that is the way it is. And that's sort of the basic two-layer structure, that the quantum world is the world looking from the past to the future. So you're all the time dealing with probabilities. The classical world is the world looking from the future to the past. So you're always talking about facts, and both are real. But you can't calculate the probability of something and also look at it as a fact at the same time. When it becomes a fact after you've observed it. And so that's, to me, that's sort of the basis of all this discussion. It's really built into the nature of things in a very deep way.
One last question, Mr. Dyson, before we conclude. You've written about science as subversion and as, in a certain sense, inherently subversive. And we began by talking about independence of mind. Do you see a connection between independence of mind and the, as it were, the freedom of the electron? And do both of these, for you, speak toward a non-deterministic conception?
Well, I think it's a foolish question. Quantum mechanics is completely non-deterministic. So that's a fact. We know that the physical world is not deterministic, and so that's not something you need to argue about.
Yes, that's actually a very powerful statement, because one does encounter quite a bit of deterministic thinking in the world, and it really is flying directly in the face of what we take to be the facts of nature as we now understand them.
Right. I mean, the fact is, of course, that it was sort of a historical accident that Newton explained the classical world, which is the world seen from the future into the past, which is deterministic. I mean, the fact that the past is just the facts, what happened, and that you can't change that. So the past is deterministic, the future is not, and it's as simple as that. And Newton explained the past; he did not explain the future. He never understood atoms.
So I would take it that only a non-reductivist mode of thinking is capable of being adequate, or at least as close to adequate as we can, to the unfolding of the present.
That's true, yes. That the unfolding of the present, I like that phrase. That's a description of the real world, yes. That it is a process, it's not just a thing. And
in that sense, the real world is inherently an activity,
yes,
not a static formula,
right,
if I can put it that way.
Right.
And only thinking that can acknowledge the dynamic reality or the dynamic fact of that unfolding is an adequate, or as close to adequate thinking as we can have.
Yes.
And in a certain sense, that is what thinking is itself a dynamic self-development, or it's not thinking at all.
Yes.
Well, I know that our time is running out, Mr. Dyson. I want to thank you very profoundly for the time you've given me today, and I know that the listeners who will encounter this will be very grateful for that as well. Thank you. Well,
thank you. I certainly always enjoy hearing the sound of my own voice.
I'm here with Mr. Freeman Dyson in his office in the Institute for Advanced Study at Princeton University.
Not at Princeton University. No, that's a mistake.
Oh, we're independent. You are not connected with Princeton University.
Well, we're connected, but we're not part of the university. Well, and they're very sensitive about that.
Oh, well, good. That's an instantiation of diversity and of you might say the move towards infinite diversity.
Yes.
I'm here with Mr. Freeman Dyson at the Institute for Advanced Study in his office in the town of Princeton, New Jersey.
Right.
Not far from the University of Princeton. Thank you very much, Mr. Dyson.
Thank you.
You've been listening to the Ralston College podcast. I'm Stephen Blackwood. Today's guest was the late mathematician polymath, Freeman Dyson. If you haven't already read his books, you have treasures waiting to be opened. They include Maker of Patterns, Dreams of Earth and Sky, The Scientist as Rebel, Disturbing the Universe, and Infinite in All Directions. You can also find many interviews, lectures, and stories about him available online. We love hearing from you, our listeners, so please feel free to subscribe, leave us a comment, or to send us a note. You can also join our endeavor to renew, reform, and reimagine higher education at www.ralston.ac. Upcoming episodes include interviews with the scholar of Russian literature, Donna Orwin, the Scottish sculptor, Sandy Stoddart, and the Nobel laureate in economics, Vernon Smith. I'm Stephen Blackwood. Till next time.